You know that feeling, right? You're staring at a math problem, maybe something with fractions or decimals, and your brain just stalls. It feels weird, backward, and just totally frustrating. If that sounds even a little bit familiar, you are definitely not alone. It turns out there's a really fascinating reason this happens, and it has way less to do with math itself and more to do with the brilliant but kind of stubborn way our brains are wired. All right, let's get into it. So let's kick things off with an absolute classic. Why is 1/10 smaller than 1/3? I mean, come on. Your whole life, you've learned that the number 10 is bigger than the number 3. So why on earth, when you get to fractions, does that rule just completely flip upside down? This isn't a trick question, I promise. It's actually a huge clue that points us right to the heart of why we get so frustrated with math. And hey, it's not just fractions, right? It's the weirdness of place value, the mind-bending logic of decimals, or even why subtraction can sometimes feel so much harder than addition, or getting square numbers all mixed up with just plain old multiplying by 2. If any of these have ever made you want to tear your hair out, then congratulations, your brain is working perfectly. The problem isn't you, it's let's call it the software your brain is trying to run. So, to find the real culprit behind all this math anxiety, we've got to look inside our own heads. We're about to go on a little investigation into cognitive science to understand the incredibly powerful and automatic mental shortcuts our brains are using all the time. Okay, the big idea here, the key concept, is something called a schema. The easiest way to think of a schema is like a mental blueprint or maybe a filing system. As we experience the world, our brain builds these little frameworks to organize all the information and spot patterns. It's how we make sense of everything without having to relearn how a door works every single morning. And here's the thing about schemas. They're both a superpower and a bit of a problem. On one hand, they're incredible. Once you finally get the hang of ones, tens, and hundreds, your brain just extends that pattern out. Thousands, millions, billions, no problem. It's a super efficient shortcut. But, and this is a big but, that exact same shortcut can become our Achilles heel. When we run into something totally new, like fractions, our brain instinctively tries to jam that new info into the old blueprint for whole numbers, even when the rules are completely, totally different. To really see this in action, we need to do something kind of weird. We need to make our own number system visible. We use it so automatically every single day that we've pretty much forgotten the incredible and powerful rules that are holding the whole thing together. To get why we have math problems, we first have to get the powerful schema we built for everyday numbers. And let me tell you, this system is an absolute masterpiece. I love this quote from Professor N.J. Waldberger. He calls it, "almost surely the greatest single development in the history of science and mathematics." That's huge. It's the engine that powers our entire modern world, and its specific design is what helped us build that powerful, but as we'll see, sometimes rigid mental model for number. So how did we even get here? Well, it wasn't overnight. It was a whole evolution. First, things were physical, counting on fingers, making tally marks in the dirt. Then we got a bit more sophisticated. We started grouping things with symbols, like using an X in Roman numerals to mean 10. But the real revolution, the thing that changed everything, was making the position of a symbol change its value entirely. And you've totally done this before, even if you didn't think of it this way. Remember those math worksheets from school where you had to write a number out in expanded form? Taking a number like 8,500,000 and writing it all out as parts? Yep, that's you literally deconstructing a number based on the exact logic of a positional system. But none of this, absolutely none of it, works without one of the most brilliant and revolutionary inventions in human history. A symbol for, well, for nothing. The number 0. Without 0 to hold a place, the whole system collapses.
I mean, think about it. The only reason 25 is different from 205 is that little circle in the middle. It's everything.
All right, so to really appreciate just how deeply our brain has internalized these rules, we're going to do a quick experiment. We're going to step outside our comfy number system for just a second to see how another one works. This is going to help us crack the code of our own thinking. Let's talk about binary. So, our everyday system is base 10. Why? Because it has 10 digits, 0 through 9. Each spot, the ones place, the tens place, the hundreds place, is a power of 10. Simple enough. Now, binary, which is the language of all computers, is base 2. It's way, way simpler. It only has 2 digits, 0 and 1, and here each position represents a power of 2. Now check out how counting works. You know how in our system we count up to 9, then we run out of digits and we have to roll over to 10? Well, binary does the exact same thing. It just happens way, way sooner. After 1, whoops, you're out of digits. So the number 2 becomes 10, which means 1, 2, and 0 ones. 3 is 11. 4 becomes 100. See? The core idea, position, and rollover is universal. The only thing that's different is how many digits you have to play with. Okay, and here we are. This brings us right to the main event. Now that we understand schemas and we've unpacked the hidden rules of our own number system, we can finally solve the mystery. Why do things like fractions feel so wrong? And here it is, the big aha moment. The reason fractions and decimals feel so frustrating is because they literally break the very rules your brain spent years and years mastering for whole numbers. They are a direct assault on that beautifully constructed schema you've got. Just look at this collision of rules. Your whole number brain says, rule number 1, a number, like 7, is always 7. It has one value. Rule number 2, a bigger number means more stuff. Easy. But then fractions come along and just throw a grenade into the whole system. Suddenly, one single value, like 1/2, can have an infinite number of names. And the craziest part, the rule that really breaks our brains, is that a bigger number on the bottom, the denominator, means a smaller piece. This isn't just new. It's the complete opposite of a core rule our brain thinks is always true. And that is exactly why comparing two big whole numbers is actually a piece of cake for us. Our schema is like, yup, got this, no problem. But the second you ask it to compare 1/3 and 1/10, your brain has to fight its own instincts. It's trying to apply a rule that is suddenly and very confusingly dead wrong. And it's the exact same trap waiting for us with decimals. Your brain is hardwired to see the number 10 and think bigger than 2. So when it sees 0.10 and 0.2, your gut instinct, your automatic reaction screams that 0.10 is the larger value. It takes real, conscious mental effort to override that impulse and apply a new, more nuanced rule. So what's the bottom line here? What does all this really mean? Well, the lesson is actually way bigger than just math. It's about how we learn and how we can get past the limits that our own thinking sometimes creates for us. Ultimately, that feeling of frustration, of banging your head against a wall with a math problem, that's not a sign that you're bad at math. Not at all. In fact, it's proof that your brain is incredibly good at its job. Its job is to build powerful mental models and defend them. That struggle you feel, that's just the growing pains of your brain being asked to build a brand new one. So the path to understanding isn't just about memorizing more rules. It's about consciously helping your brain build that new, more flexible schema. You do this with real, concrete examples, literally using pizza slices for fractions or money for decimals. You have to focus on why the math works, not just how you get the answer. And maybe most importantly, you have to actively acknowledge, okay, brain, I know you think bigger is bigger, but that rule is on pause right now. Let's learn the new one for this situation. And that leaves us with one last kind of mind bending thought. Our struggle with math is a perfect case study of how our own mental models can limit us. And it makes you wonder, doesn't it? What other obvious truths in our lives about our work, our beliefs, about other people might just be really powerful schemas that we've simply never been forced to question?